Good evening, everyone.
Good evening, sir.
So we were continuing.
Sir.
Yes. Good evening. So I hope you know you have to be active during the classes. This is for everyone. So everyone has to be active during the classes. Okay. Either your camera should be on or you should be active so much that I know you are there.
What is it, sir?
Yeah, what happened? So just take care. Either you should be no delay in response or your camera should be on. So either of them you should arrange.
Hello, sir. Good evening, sir.
Good evening, sir.
Good evening, there. So let's continue now. We were doing the chapter carbon and its compounds, right? So what is the valency of carbon? How many electrons are there in carbon?
6.
6. And what are the valence electrons?
4.
Okay, 4 there are valence electrons. Then we did about the electron dot structure. So I want all of you to draw the electron dot structure of nitrogen. I think everyone can do now. Electron dot structure of nitrogen N, oxygen, hydrogen, carbon, fluorine, chlorine.
Good evening, sir.
Yeah, good evening. So draw the electron dot structures of these elements.
Yes, sir.
And when I ask you to show, just show it. Okay, there you see. So there is how you will show your work. There, how will you be able to show your work? Okay, there, send it to me. As soon as I tell you to send, so send it to me. Okay. So see, this was quite easy, knowing the valence electron of each element. For example, nitrogen has 5 valence electrons. So 5 valence electrons. So nitrogen will be represented as N. The valence electron will be represented with 5 dots. Okay. Then oxygen can be represented as O with 6 electrons around it. So the number of electrons and their position, it can be anywhere. It's not necessarily wherever I have represented. You can represent it anywhere. So this is oxygen. Then we write for hydrogen, we just add 1 electron. For carbon, we add 4 electrons. So they can be either like this or it can be like this also. Carbon with 2 electrons here, 2 electrons here. It can be either like this, carbon with 3 electrons on one side and 1 electron on the other side. We generally do not represent with 4 electrons on one side.
Can you show oxygen once again?
Okay, so oxygen is here, which is you have represented 6 electrons. Yes. This one. See this one? So see, you can represent maximum of 2 electrons to 3 electrons on one side. Okay. This is generally, I will discuss why we represent a maximum of 3 electrons on one side.
Completed, sir.
So for fluorine, okay, Moksha, show for fluorine. Just one minute. Let me stop share and then I'll. Yeah, it's correct. Correct. You can keep it.
Sir, what is after fluorine, sir? Can you show it once?
Fluorine.
Fluorine. Okay.
So you have fluorine. It tastes well. So everyone done for chlorine also?
Sir, one doubt,
Yes,
sir.
sir. Yes, sir.
Sir,
Okay.
from K,
Yes.
sir, from L shell, then it will first go to N shell, sir.
Just speak up loudly, Aryan.
Sir, KLMN shells and then sir for valence electron. So after L shell, sir, then where it should added, sir, for chlorine?
For example, if you want to see for calcium, right?
Yes, sir.
So the calcium, it has atomic number 20. So there are 20 electrons, and to write down the configuration, it will be KLMN. So you have 2, 8, and you can't have 18 electrons here because if you write here 18 electrons, then M becomes the outermost shell, and outermost shell cannot have more than 8 electrons. Okay, so it has so
Yes,
you
sir.
remove this 18 electrons. There are not 18 electrons in the M shell. You just get here 2, 8, 8, and how many electrons will be there in N shell now?
2, sir.
2. Okay. Sorry, it would have been 10 electrons. So it can't accommodate 10 electrons since it would become the outermost. So this is the configuration. If you want to know what after N shell, okay. So generally after N, if the electrons are moving to the shells after the N shell, if they are moving after the N shell, so we generally represent with numbers and not the symbols. So in that case, we call this as the first shell, second shell, third shell, fourth shell, fifth shell, sixth shell, seventh shell, so on. They are also called as principal quantum numbers.
Okay, sir.
They are called principal quantum numbers. So obviously you will find the different methods of arrangement. Got it? So now I think if I have to write the electron dot structure for calcium, so it will be calcium has 2 electrons, it will be represented like this. Now see, we had seen about the two types. In the last class, we had studied about the ionic bond. Does anyone remember what is ionic bond? Yes, what is ionic bond?
Sir, the bond between two ions.
Okay, very good. The bond between two ions. The bond formed due to complete transfer of electrons. Due to complete transfer of electrons, or we can also call the definition like the bond between the two ions. Okay, so both the definitions are correct. The bond formed between two ions that we call as the ionic bond, or the bond formed due to the transfer of electrons. So both the definitions are same. For example, suppose I explain how sodium chloride is formed. Let's say I want to explain how sodium chloride is formed, how magnesium chloride is formed, how suppose I have to say HCl is formed. Okay, so I need to show the formation of these compounds. So clearly I know that in this compound, sodium has 2 electrons. So I will write here sodium Na has 1 electron in the outermost shell, and chlorine has 7 electrons in the outermost shell. So it will be like this: sodium has 1 and chlorine has 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. So chlorine has 7 electrons, sodium has 1 electron. Now it's like this: sodium donates 1 electron to chlorine. So when sodium donates 1 electron, sodium itself becomes Na plus. It becomes an ion, which is Na plus, and chlorine gains an electron to become Cl minus, which now its electron dot structure would be like this: 1, 2, 3, 4, 5, 6, 7, and 1 electron from sodium. So chlorine has now become -1 and sodium has now become -1, a positive one. So there will be a strong electrostatic force of attraction between the two holding each other. So here Na plus and Cl minus will hold each other with the strong ionic bond in between them. Got it? So Na plus is held with the chloride ion with strong ionic bond. I can write it as Na plus holds Cl minus like this. In the same way, can anyone tell me how the bond between MgCl2 will be formed? Okay, first try with HCl. Let's try with HCl. How the bond is formed in HCl? Yeah, Aryan, how will the bond be formed in HCl?
Sir, H with one ion, sir.
Okay, which one will form the positive ion and which one will form the negative ion?
Sir, hydrogen will form the positive ion and chlorine will form the negative ion, sir.
Okay, so hydrogen will form positive ion. Initially, hydrogen has 1 electron and chlorine has 7 electrons. So we make here chlorine with 7 electrons. So 7 electrons of chlorine: 1, 2, 3, 4, 5, 6, 7. So these are the 7 electrons with chlorine. And now if hydrogen transfers 1 electron to chlorine, so hydrogen now becomes H plus and chlorine now becomes -1. So a strong ionic bond is set up between them.
Sir,
Yes.
are we supposed to write chlorine in brackets?
Yeah. If see, if you are writing it with the in the ionic form, you need to write this with the bracket. So Cl -1, hydrogen -1, and also it's not necessary. You can write it without the square brackets. Okay. You can write it without the square bracket. You can write it this way also: H plus Cl minus. No effects. Then try to write the how will the ionic bond be set up between MgCl2? Anyone has got the ionic bond between MgCl2? How will it be formed?
Yes, sir.
Okay. So yeah, Moksha, how will this bond be formed?
Sir, first it will get divided into Mg plus and Cl minus.
No. How many electrons does Mg have?
2.
2, sir.
2. So how is Mg going to donate the electrons?
So the chlorine gets divided. So one electron for one chlorine, another one for another
Yes.
chlorine.
So here we have 2 chlorine atoms. We need to write another chlorine atom here with 7 electrons. So this chlorine atom has 1, 2, 3, 4, 5, 6 and 7 electrons. Now 1 electron being transferred to each chlorine. So 1 electron being transferred to each chlorine, then your magnesium becomes Mg2 plus, your chlorine becomes, here you have Cl negative ion, so you have 2 chloride ions. They both are combined to form MgCl2, and bond formation you can show something like this, like magnesium being bonded to the 2 chlorine atoms like this. Here Mg having +2 charge, chlorine having -1, -1 like this you can show. Understood this?
Sir, or we can write Cl in brackets minus and we could put 2 in
Yes.
the bottom.
So this is the way that we have written. You can use your square brackets if you want. We generally use square brackets for complex ions. Okay, we don't use square brackets for simple ions. So chloride is a simple ion, so we don't use a square bracket. Understood all this? Now let us see. Let us try to get some of the properties of ionic compounds. So what are the properties of the ionic compounds?
They have low melting and boiling points.
Low. They have a high melting and
Sorry, sir. High, sorry.
yes. So ionic compounds, they are also called as electrovalent compounds. Ionic compounds, they are also called electrovalent. So electrovalent compounds, they have strong or they have high melting and boiling points. Any other property? What about their electrical conductivity?
They conduct electricity.
Yes.
They don't conduct electricity in solid form, but they conduct electricity in molten form.
Okay, good conductors in molten and solutions. Molten and in the form of aqueous solution. Whenever they are in the form of their aqueous solutions, if they are in the form of aqueous solution or if they are in the molten form, so then they are good conductors. Okay. Any other points? What about the forces of attraction?
They are usually hard, but
Okay. They are hard. So strong forces of attraction. Anything else about them? Okay, what can we say about their structure? Is it a crystalline structure or an amorphous structure? Yes, they are crystalline solids. Okay. So ionic compounds or electrovalent compounds, they have high melting and boiling points. They are good conductors in their molten and aqueous solution, molten state and aqueous solutions. They have strong forces of attraction and they generally occur as crystalline solids. Got this? Now the second method of bond formation. What do you think if suppose carbon wants to form the bonds with hydrogen? So how will carbon form the bonds with hydrogen or oxygen? Do you think
Sir,
carbon
could
will...
you show the previous page, sir?
Okay.
Done, sir.
Okay.
7
Yes.
minutes, sir. Completed, sir.
Okay. So now see, if carbon tries to form a bond with hydrogen, or if carbon tries to form a bond with oxygen, okay. So do you think that carbon will be able to accept 4 electrons from hydrogen? Yes. Can carbon accept 4 electrons from hydrogen? So the answer is no. Carbon cannot accept 4 electrons from hydrogen. Okay. The reason being that we studied in the beginning that it's very difficult for a nucleus of 6 protons to hold 10 electrons. So how does the carbon form bonds? How can carbon form bonds with 2 oxygen atoms? How can carbon form bonds with chlorine? Okay. So see, now carbon adopts another strategy for making the bonds that we call as the covalent bond. That is bond formation by sharing of electrons. So this is covalent bonding. Covalent bond, or you can say it bond formation by sharing of electrons. So covalent bond is the bond formation by the sharing of electrons. So see, you have carbon, hydrogen, carbon, oxygen. So how does carbon forms bonds with itself? Suppose carbon forms bond, we see the bond formation of carbon and oxygen. So carbon is not in a position to donate all the 4 electrons. See, we have studied the carbon dioxide. So it is not possible for this carbon and to give out all its 4 electrons. Can carbon give all its 4 electrons?
No, sir.
And even if carbon donates all the 4 electrons, then the oxygen, they will be able to hold two electrons, and but still it will not be able to form C plus 4. So that's not possible. See what happens now. Carbon has here 4 electrons. So carbon has 4 electrons, and now it shares the electron. It shares the electrons with oxygen. So it's something like this. Now you have oxygen on both sides of carbon. So these oxygen, they share the electron pairs with carbon. So they have 6 electrons with them. So what oxygen does, oxygen shares the 2 electrons with carbon. So now it works something like this. Now nothing much special. One of the guys who told me that he just called to Arvind sir and then recognize that he is in the school campus or not. So I will call him. So I'm calling you, but you are unable to receive that. It's all about the Palki and okay, so see, it behaves something like this. So your oxygen holds the two electrons of carbon and is able to satisfy its valency. So in this way, your oxygen is holding the two electrons of carbon and it satisfies its own valency now. So the valence, if you try it like this, so the valency of carbon is satisfied. So the valency of oxygen is satisfied. If you count the number of electrons for each of the oxygen, so now each of the oxygen is having 8 electrons. Can you just count for here? You have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 electrons for this oxygen. There are 8 electrons for this oxygen also. 1, 2, 3, 4, 5, 6. So there are 8 electrons for each of them. So their all valencies are satisfied. Now, if we look for carbon, let us see how carbon has satisfied its valency now. Everyone is satisfied, but not if carbon is not satisfied, then how will it? So see now carbon is also satisfied. Carbon is sharing its electrons, but like this. So see, now carbon also has 8 electrons. Can you check? Just check. Carbon also has 8 electrons. 2, 4 are their its own electrons.
Sir,
He left.
Okay, welcome all again.
Good evening, sir.
See, we were here. Okay, we were drawing the electron dot structure and the formation of carbon dioxide. And we observed that how carbon is able to satisfy its valency in the formation of carbon dioxide. So see, during the formation of carbon dioxide, oxygen is not taking the electron of carbon completely. Rather, it is sharing its electron. Okay. Sharing means the electron that belongs to carbon, it will be compensated for oxygen also. And two electrons of oxygen will be shared with carbon also. One very important condition for covalent bond formation is that the number of electrons that will be shared by each atom, that will be shared by two combining atoms, will remain the same. That means, it simply means, if this carbon is sharing two electrons here, suppose here this carbon is sharing two electrons with this oxygen, so this oxygen will also share two of its electrons with this carbon. This is the condition. If you are ready to accept two electrons from carbon as a share, so you also are ready to donate two electrons as share. So this is how the covalent bond formation works. So here, if carbon is using these two electrons from, if carbon is providing two electrons to this oxygen, so as a result, this oxygen will also provide two of its electron as a share. Okay, and hence the valency of all of them is satisfied. If you count it, what is the total number of electrons for surrounding carbon? There, what is the total number of electrons surrounding carbon?
8, sir.
8. Okay, and surrounding this oxygen, surrounding this first oxygen?
8, sir.
8. And for this oxygen?
8, sir.
8. So can I say that the valency of all of them is satisfied?
Yes,
Yes.
sir.
Yes. Or the outermost shell should have 8 electrons. So the valency of all of them is satisfied. Now, in the same way, can we try to form NH3? Ammonia. NH3. So ammonia also does the bond formation by the covalent bonds. So it's nitrogen, nitrogen has 5 electrons around it. 1, 2, 3, 4, 5. And how many electrons does nitrogen require to complete its octet? Yes, how many electrons are required by nitrogen to complete its octet? Abhinav?
Uh, two,
Currently,
three,
nitrogen has 5
three.
electrons, 3 electrons. So each hydrogen can donate only 1 electrons. So hydrogen will donate 1 electron and accept also 1 electron. So here we have the electron of hydrogen. Now see, each hydrogen will be accepting 1 electron also and donating 1 electron also. And we will observe that the valency of each of them is satisfied. Okay, so see, this is our nitrogen. Okay, let's see for hydrogen. So see, this one is for hydrogen. This one is for hydrogen. And we can see that valency of carbon is valency of nitrogen is valency of hydrogen is satisfied. Can we say that the valency of hydrogen is satisfied? Yes or no? Is the valency of hydrogen satisfied?
Yes, sir.
Yes, sir.
So since hydrogen can accommodate a maximum of 2 electrons only in its outermost shell, that's the K shell. So it has a valency of 2 and it has accommodated 2 of its electrons. Now see, nitrogen is sharing all the electrons. Nitrogen is sharing 3 electrons, so it is also gaining 3 electrons here. So if you count the total number of electrons with nitrogen, so nitrogen has a total of 8 electrons. Hydrogen has a total of 2 electrons each. Got it? So now the valency is satisfied for all of them. Yes?
Yes, sir.
Yes. So this is covalent bond formation. I hope everyone has understood the covalent bond formation. Okay, as a homework, you can try to make the covalent bond formation in methane, covalent bond formation in what shall I give? MgO, magnesium oxide. Okay, try these two to form the covalent bonds. Okay, bye all of you. See you again in next class.
Bye, sir.
Thank you, sir. Bye, sir.